Okay, so welcome to part 3 of machine learning series, our car price predictor. Quick recap before we jump in. In part 1, we built the Python web scraper and pulled car listings from Park Wheels. We scrapped around 59,000 records and fields like title, price, year, mileage, fuel, engine capacity, transmission, and bunch of other details. Then, in part 2, we took the raw data and cleaned it properly using pandas, handled missing values, fixed data types, removed noise, and basically turned this messy data set into something a machine learning model can actually learn from. So now the dataset is pre-processed and ready. In this video, we will finally do the main thing. We will choose a machine learning model for training and then train it, evaluate it, and then use it to make predictions step by step so you can follow everything. All right, let's start without wasting any more time.
For this project, we're going to use XGBoostRegressor, and the reason is simple. It works extremely well on structured tabular data like this. Car price depends on mix of numeric and categorical features, and XBoost is very good at capturing nonlinear relationship between them. Under the hood, it builds an ensemble of decision trees sequentially, where each new tree focuses on correcting the mistake made by previous ones. It handles features interactions automatically and is robust to noise and performs very well even the data isn't perfectly clean. On top of that, it's fast, scalable, and includes built-in regularization to reduce overfitting. All of this makes XBooks a strong, reliable choice for a real-world price prediction problem like this. Okay, let's start and jump into coding. First things first, we're going to import train test split so we can split our data between training and testing. So let's say from sklearn.model selection import train test split. And here, okay, you have to differentiate now what are your features and what is your target. In our case, if I run this cell, you can see that our target is price for obvious reasons. We are predicting price here, and title, year, mileage, fuel type, engine capacity, transmission, city, they're all features. So based on these features, we will predict price. So features, we're going to call them X, and data frames. Okay, so in our features, we have title. Uh, Sorry about that. We have then what's next? Year. Then we have mileage and engine capacity. Then we don't have price, we have city. And transmission, I wanted autofill to complete it, but let's just write ourselves. Our spelling's correct. Okay, they are correct. And what is left? Okay, fuel type is left. Fuel type. Perfect. So these are all features. Based on these features, we will predict our price. Now we have our y, which is our prediction, our target. So we'll predict y. Now let's split it between training and testing. So we have xtrain, then we have xtest, then we have ytrain, then we have ytest, that's equals to train test split, and plus we have to pass our features, and we have to pass our target, then test size is equals to 0.2, which means 20% of data is going to be our test data and rest of it is going to be our training data, and random state is 42. This will just include the randomness, so it doesn't just memorize the data, it learns from it. So that's just for our splitting the data and splitting the features and defining our features. All right, so now I'm defining which columns are categorical columns and which ones are numeric columns, and we're going to do some pre-processing on those columns. So for that, I'm going to import some new modules here. Uh, I have already imported this compose sk from sklearn.compose import column transformer, and I'm going to import one more thing from sklearn.processing import one hot encoder. So what are these two? I'm going to just tell you right now. So add a new cell, and first of all we're going to define our categorical columns. So what are categorical columns? As we know, machines and our machine learning models, they all understand numerical values, and they do not understand a raw text like city, transmission, fuel type. All these are categorical columns. So I'm going to separate them, and I'm going to define categorical columns. So we have first title, then we have um, a field type, then we have city, and then we have transmission type. So these are our categorical columns. Now we have to define our numeric columns. So in the numeric columns, we have all the numeric values columns, which are mileage, engine capacity, and year. Now we're going to do some pre-processing it. Now I'm going to build a column transformer. Think of it like a smart pipeline router. It sends categorical columns through one process and numerical column through one process. So I'm going to name it pre-process and column transformer. So it takes a parameter transformers. And the transformer is a list of the processes. So first one is categorical columns. So we are going to apply one hot encoder. So what is one hot encoder? I'm using it because basically it turns each categorical column into its own binary column, so the model can work with it. So yeah, that's basically it. It turns those categorical columns into 1, 0. The reason this works so well is that it prevents the model from assuming any order of ranking categories, which would completely break the learning process. The next thing is we are going to define a path for numerical columns, and we're not going to use standard scalar, but we are going to use pass-through, which means we're just going to pass through our numeric values as they are. We're not going to do anything with this because they're already numeric values. All right, and now we're defining the actual machine learning model. So first of all, we need to do some imports. First, from sklearn.pipeline, we have to import pipeline, and from XGBoost, it is not installed, so let's install this first. Pip install XGBoost. Okay, successfully installed. Let's go back here. Let it do the indexing. Is it indexed? I think I have to rerun the Jupyter notebook. Okay, the issue was with the interpreter. I've changed it back, and now it is installed. Now let's go back and use it. So we have to define the model, which is going to be our XGBoostRegressor. Now the important thing here, I'm going to define some hyperparameters here. First of all, I'm going to start with an estimator, which I'm going to give a 500. This is basically I've set the number of trees which gives the model enough capacity to learn complex pattern. So this will create 500 trees, you can say that. So if you go deep into the regressor algorithm and this XGBoostRegressor, it just makes trees connecting to the previous ones. So I have given this an estimator of 500 trees, so it can create 500 trees and can have enough capacity to learn complex algorithm. The next thing is we have to define the learning rate, and I'm going to give it a 0.05. So the learning rate is kept so small because the model can learn gradually instead of overfitting too quickly. And after that, we have max depth of 6, and then we have subsample, and I'm going to give it, it should be 0.8, and then column sample, and at the end we have random state for 42, and then as I'm going to use a GPU, I have an RTX 5080, so tree.method is hist, and the device is CUDA. Perfect. I have only one GPU, so there's no point of defining the number of GPU, the index of GPU. And I have limited the tree depth so each tree stays reasonable simple, and I'm using subsampling on both rows and features here to add some randomness and improve generalization. I've also set a random state so everything is reproducible, and since I'm running this on NVIDIA GPU, I have used CUDA. After that, I'm going to create a pipeline. So this is important because it is the chain of processing and the model training into a single object. So the data gets cleaned, encoded, and passed into the model automatically. So for the pipeline, I'm going to say pipe is equals to pipeline, and then we have to define our steps. So the first step should be the prep, and for the preparation we have to just run the processes which we defined up here, and then just make the model. Here we have the model. Now we have to take the prediction. So we'll write pipe.fit xtrain and ytrain, and after that print if your model is ready, exclamation mark. So just that's it. Our machine learning model is ready and working. Let's run it. Before that, I think I should run all above cells. And now I think I should run this one. Your model is ready. It just took 2 seconds. If you're on CPU, it may take some more time, like 30 to 40 seconds, but it will be quick. Now, I will just leave that finding error, absolute error, or mean square error to you guys. You guys can do all that. What I'm going to do is I'm going to test it. So how I'm going to test it, or I'm going to open Chrome. I've Chrome opened to a separate tab. I'm going to go to path wheels. Here I'm going to take data from one car which is posted recently, as my data is like 2 weeks old. I scrapped it at 1 or 2 weeks ago. So we have the name of the car. Let's take any car. Let's take this one. We have Toyota Race Access. Then we have city. Let me define the variables first. Then we have mileage. Then we have engine capacity. Then we have the year, and then we have fuel type. After that, we have transmission. So now let's get this information for this particular car. So it's not registered, that's why the price is so low. Uh, so let's take any other car. Let's take this Honda Civic. The mileage is 84,000. Again, mileage. The mileage is going to be, I think, a floating point number. Yes, the mileage should be float. Then we have engine capacity. Engine capacity should also be float, and its engine capacity is 1800 cc. Then we have the ear. I think ear is also float. The year is 2014. Then we have fuel. It is petrol. Yes, it is petrol. Transmission. It is automatic. And we have city left. In which city it is registered? It is Karachi. Now we have to define a data frame. So pd dot data frame. I'm just, testing it. Later, in the next video, as we're going to make a web application, I will just automate it and create a beautiful web dashboard in which you just enter the things. I'm just testing it here right now. Should be dictionary. So first we have title, then we have year, then we have mileage, engine capacity, city. Thank you, autocomplete, for doing all this for me. And at the end we have fuel. And what we have to predict is the price. Predicted price. So pipe dot predict, and we have to pass the car, and let's print it and see what it is. Okay, we got an error using warning. Relation to matrix. Router while is on CPU. Um, should be. Let's do this. Model is ready. Okay, so it predicted a price of 42 lakhs. Let's see how accurate it is. Okay, um, it's a big difference. Let's try with some other car. I'm not happy with this. If it is in a range of like 5 lakh something, then I think it will be okay. Okay, so if you can see in the description, a two-piece mirror separated due to scratch. So these things also reduce price for the of the car, which we have not included. So let's try with another car. Let's take this one, the Atsumira. Copy this and get back to our paste it. And the next thing is city. We have, okay, it's unregistered. Let's paste it here and see what does that give us. We have 660. Engine capacity is 660. Mileage is 17,000. And it's 2023. Where's the year? 2023. Petrol automatic. Petrol automatic, and everything else is fine. So let's run it. 35. Okay, it's, oh wow. This prediction was very close. Okay, this prediction was very close. That was impressive. Okay, the one last one, and then we're going to end this video. Which one, which one, which one? Take any random one. Let's take this. These are totally random. Okay, Honda Civic. Here, registered in Punjab. You have to check the city registered in. Okay, no city here. No worries. We have Punjab. We have engine capacity of 1800 cc's. Mileage of 96,000. 96,000. And the year is 2016. Rest is good, and let's take this prediction. 53, 43. This one is a bit off, quite off. 96, 5 piece. Okay, you can see this 5 piece touching. That means that's a very negative thing when you are purchasing car here in Pakistan. So if you look at one aspect, this model is very, very accurate. This is because we have not provided it the whole data. If we want it to be like pinpoint accurate, we have to parse this description, convert this description into some meaningful data, and then train it too. So for now, I think this one, it is very accurate. I will again leave this to you guys. You guys can extract the description, create more features, and train our model on those features. I'm ending this video here, and in the next video I'm going to create a web application using Django and deploy it on the server. Thank you for watching, and don't forget to subscribe.